Welcome back to the ATA Chapter Channel. Today, we are diving deep into the incredible digital nervous system of the Airbus A380. We're talking about its ATA-27 fly-by-wire flight controls. I mean, just look at the sheer size of this aircraft. You can imagine that for a plane this massive, a super advanced control system isn't just a cool feature. It is an absolute necessity. The A380's fly-by-wire system is really the only way a pilot can manage this giant with the kind of precision and safety that's required.
The whole architecture is actually pretty elegant when you break it down. You can think of it like the plane's own digital nervous system, and it's built on 4 key functional blocks. So what we're going to do is follow the journey of one single pilot command all the way from the pilot's hand to the plane's brain, then to its muscles, and finally, right back to the pilot's eyes.
So here's our flight plan for this explainer. We'll kick things off with the pilot's intent, then move to the central brain. After that, we'll see how those signals become actual force, and finally, we'll close the loop with feedback and backup systems. Okay, let's get into it. Part 1, the pilot's intent. You know, it all starts right up front in the cockpit. The entire journey begins the second a pilot makes a physical move. Now, this is super important to get. Those side sticks, the rudder pedals, all those levers, they aren't physically connected to the control surfaces with cables and pulleys like in older planes. No way. Instead, they act like high-tech translators, turning the pilot's physical actions into an electrical language that the rest of the airplane can understand. All right, so that electrical signal has been created. Where does it go next? Well, it travels from the cockpit straight to the computational core of the aircraft. This is the real heart of the fly-by-wire system.
This block is literally the brain of the whole operation. It gets the pilot's command, and then it looks at thousands of data points, things like the plane's speed, altitude, and angle of attack, and it calculates the exact orders for the control surfaces needed to make the plane do what the pilot wants. And here's the kicker. To make sure this brain is unbelievably reliable, it's not just one computer, it's 6 of them. The entire philosophy of this system is built on a foundation of extreme redundancy, and it all starts with these 6 powerful, interconnected computers.
So how do these 6 computers work together? Well, they're split into 2 distinct groups. First, you have 3 primary systems, we call them prims, and they handle all the complex flight control laws. Then you have 3 secondary computers, or CES. They act as backups, but they also have their own jobs, like directly controlling surfaces like the spoilers.
Okay, this is where it gets really clever. To keep everything organized, the system uses a hierarchy. At any given moment, one of those 3 prims is designated as the master. This master prim does all the main thinking and then sends one unified set of commands to the other computers. This whole setup prevents any conflicting orders and makes sure there's a single clear voice directing the aircraft. So with 6 computers all chattering away, you might be wondering, how does the system manage all that information? Well, that's the job of the Flight Control Data Concentrators, or FCDCs. They collect data from all the prims and secs and then send it to the right place, whether that's the cockpit displays, the warning systems, or maintenance. You can basically think of them as the system's air traffic controllers for data. Okay, part 3, from signal to force. The command has been computed, it's been sent out, but now the system has a huge challenge. How does it turn a tiny digital signal into enough raw physical force to move a massive control surface against tons of air pressure? Well, this is where we meet the muscles of the system, the actuation block. These incredibly powerful hydraulic and electrohydraulic actuators are the heavy lifters that translate the computer's electrical orders into real physical movement. And you're probably sensing a theme by now. It is all about redundancy. Instead of just relying on one type of actuator, the A380 uses 3 different kinds, each with different power sources. It's just layer upon layer of safety. Let's break this down. First, you have your conventional actuators, which run on the plane's main hydraulic systems. Pretty standard stuff. But then you have electrohydrostatic actuators, or EHAs, and these things are just awesome. They use electrical power to create their own hydraulic pressure right where it's needed. They're totally self-contained. And finally, you have the electrical backup hydraulic actuators, or EBHs. These are hybrids, kind of the best of both worlds. They can run on the main hydraulics, but if that fails, they can switch to electrical power and work just like an EHA. It's an incredible safety net.
All right, our final section, number 4, closing the loop. So the pilot gave a command, the brain processed it, and the muscles moved. But we're not quite done. For the system to be complete, 2 more crucial things need to happen. It has to report back to the pilots, and it needs an ultimate failsafe.
The indicating block is all about closing that communication loop. It takes feedback from the control surfaces and sends it right back to the cockpit displays. This is so important for the pilot's situational awareness, because it confirms that the plane is actually doing what they told it to do. And just like that, the journey of our little electrical signal comes full circle. The results of the pilot's command pop up right there in front of them on the primary flight display, the system display, and the engine/warning display. The pilot gives a command and the system shows them the result. Simple as that.
But let's ask the really tough question. What happens in the absolute worst-case scenario? What if all 6 of those flight computers, all the prims and secs, were to fail? It's almost unthinkable, but Airbus has one final bulletproof layer of protection for just that. In that kind of emergency, the electrical backup system kicks in. A completely independent computer called the Backup Control Module, or BCM, takes over. And here's the brilliant part. It's an analog system. That means whatever weird digital glitch might have taken out the main computers, it can't touch this one. It bypasses everything else and gives the pilot direct, essential control to safely fly and land the aircraft. When you put it all together, the A380's flight control system is a true masterpiece of redundancy, logic, and raw power. It takes a pilot's simple thought and turns it into aerodynamic force in the blink of an eye. It really makes you wonder, as this technology keeps getting better and better, what will the next generation of these incredible digital nervous systems even look like?